Superman is considered by some to be the strongest superhero of all. So today we're analyzing a scene from the 2006 Superman Returns and try to calculate how strong Superman really is. So let's move on and apply some physics to the superhero's universe. So to calculate Superman's strength, let's use this particular scene here from the movie, where he's saving this airplane from falling in this baseball field, okay? So the airplane is a free fall and he's able to stop the plane just before it hitting the ground. Alright, so how are we going to calculate his force? Well, first we need to know the time it took for Superman to stop the plane. So if you take this first frame here where he touches the nose of the airplane and this last one where the airplane finally stopped, it took 30 seconds for it to happen. Now I'm also going to assume that the airplane is in a free fall for 4,000 meters, let's say. So his velocity at that point would be 280 meters per second, okay? That's the velocity where Superman touches the airplane. Very good. With these two informations, we are able to calculate the acceleration, okay? Actually, the deceleration of the airplane. And we can do this by using the velocity formula in an accelerated motion. So we have the final velocity, which is 0, right? Superman is going to stop this airplane. The initial velocity, we just assume that's 280 meters per second, and it took 30 seconds for everything to happen. So the acceleration is negative 9.33 meters per second squared. This negative sign, remember, it means is in the opposite direction of Superman, all right? Very good. Now we can calculate his force, but before calculating the force, we need to know the mass of this huge airplane. So this is a Boeing 777, and when it's empty, it has around 135,000 kilograms, and at its maximum capacity is around 250,000 kilograms. Because the airplane lost its two wings, and it has some passengers, I'm going to assume that the mass of this airplane is around 200,000 kilograms. Alright, now we can use Newton's second law of motion, where the net force is the mass times the acceleration. The net force in this case is the Superman force and the weight of the airplane. So we can calculate the Superman force using this formula. We have mass times acceleration, which is the mass of the airplane, and the acceleration we've just calculated, and mg, which is the mass of the airplane, and the gravity acceleration. Note here that I'm adding these two accelerations, okay, because it's the force the Superman is doing against the airplane. So he has to overcome these two accelerations, right? The gravity and the airplane acceleration. So when you plug in the values we've assumed, we find out that the Superman force in this particular scene is of 3,828 kilonewtons. Just for you guys to have an idea, this is the force of not only one, but two main engines of the space shuttle, which is a very impressive force for only one person, but maybe only a fraction of Superman's strength.
Thank you for watching this video. Hope you have a great day ahead, and we'll see you later.